In this video, we are going to look at how to find the general solution of a differential equation that looks like this. X squared dy by dx is equal to x squared plus y squared. Now, let us begin. So, if you look at it keenly, we are going to realize that it's a homogeneous differential equation. So we begin by dividing throughout with x with the highest power. So we shall have our x squared divided by x squared dy by dx is equal to x squared divided by x squared plus y squared out of x squared. Now, if we simplify this, you clearly see that it turns out to be dy by dx is equal to 1 plus y squared out of x squared. Yeah. Now, if we write it very well, it can turn out to be dy by dx is equal to 1 plus this is y out of x everything squared. Now, for homogeneous differential equations, it always tells us that we have to let our y equal to ux. This means that when you make a u the subject, we shall have u is equal to y out of x. Yeah. Now, continuing like that, we differentiate this y, and then we shall have dy by dx is equal to u into 1 plus x du dx. Yeah. Now, when we simplify this, we end up having dy by dx is equal to u plus x du dx. Now, this dy by dx that you have obtained is going to be substituted there. Now, when we substitute it there, we shall have u plus x du dx is equal to 1 plus, now the other one becomes u squared, this becomes u squared. We collect like terms together, On collecting like terms together, we take this u this side. Taking it there, we shall have x du dx is equal to u squared minus u plus 1. Yeah. Now, we can separate variables here. On separating variable, we have 1 out of u squared minus u plus 1 du is equal to 1 out of x dx. So we have separated variables. So we can even go further now. The next step is to begin integrating. So if we begin to integrate, we shall have the integral of 1 out of u squared minus u plus 1 du is equal to the integral of 1 out of x dx. Now analysis begins. If you look at this keenly, it does not have roots. Now, if it doesn't have roots, it goes for completing squares than substitution. completing squares turn substitution. Now when we complete squares turn substitution, so completing square for u square minus u plus 1, we shall have u minus half everything squared, then minus half squared plus 1. Yeah. Now when we simplify this, we shall have u we shall have u minus half square, then minus 1 out of 4 plus 1, which eventually becomes this one is u minus half squared and then plus 3 out of 4. Yeah. Now after having that, we substitute it back. Now on substituting it back, we shall have our integral of 1 out of 3 out of 4 plus u minus half squared u is equivalent to integral of 1 out of x dx. Now we begin the integration. Yeah, integration on the right hand side is easy, but now we have to deal with the integration on the left hand side. So integration on the left hand side, so we come and relate, so we use tan substitution. Yeah, if you haven't watched my video about tan substitution, I'm going to link it in the description. You can go and watch it. So we have 3 out of 4, so plus u minus half square is equal to 3 out of 4 plus 3 out of 4 tan squared. Since we are using u, we can call this suggest a letter in the comment section, but we can call it p for example. Yeah, tan squared p. So this cancels with that, and then going further to simplify, we shall have, now we go slowly, u minus half square is equal to 3 out of 4 tan squared p. Now applying square root on both sides, so we end up having, applying square root on both sides, we end up having u minus half is equal to root 3 out of 2 tan of p. Now we can differentiate both sides. So when we differentiate both sides with respect to u, differentiating both sides with respect to u, we shall have 1 is equal to root 3 out of 2 sec squared p dp du. So our aim is to make it du the subject. So on making it du the subject, our du will equal to now our du becomes root 3 out of 2 sec squared p dp. So we substitute it back. Where are we substituting it back? We are substituting everything where we are substituting them here. We are substituting them there. So we go back When we go back, we shall have integral of 1 out of 3 out of 4 plus 3 out of 4 tan squared p times root of 3 out of 2 sec squared p dp is equal to the integral of 1 out of x dx. Yeah, so finalizing that, so this is integral of 1 out of 3 out of 4 into 1 plus tan squared p times root 3 out of 2 sec squared p dp. So this can cancel with that, and this is eventually ln x plus ln k. Ln k is just the c. So here we can reduce. This goes once into 3. We have root 3. We are going to also reduce for half, but slowly, such that everyone understands. So this will remain with 1 out of 2, then out of root 3 out of 4. So dp is actually ln x plus ln k. Simplifying this, we can have, this is the same as 1 out of 2 times 4 out of root 3 dp is ln kx. So this can by 2 once. So eventually we have simplified that. So this remains as 2 out of root 3 integral of dp is actually equal to ln kx. Now going further, so this is the same as 2 out of root 3 p is equal to ln kx. Now what is our p? So you have to go back and get p. Where are we getting p from? We are getting p from where? We are getting p from here. So we are getting p from here. Yeah, we are getting p from there. So if you keenly look at it, so our p is going to be so our p, so first our p is tan inverse of what? Our p is tan inverse of let me create space. Tan inverse of u tan inverse of 2 out of root 3 into u minus a half. So you can even go back and see it. From here. If you can see it from here, it is tan inverse of 2 out of root 3 into u minus a half. So that is that. So we go back. So when we go back, we substitute it back where there is p. So we shall have we shall have 2 out of root 3 tan inverse of 2 out of root 3 into u minus a half is equal to ln kx. So finalizing, we are putting back our u, but before we put back our u, we can have this as that we have 2 out of root 3 u minus a half is equal to tan of who? Of root 3 out of 2 ln kx. Yeah, so this is multiplied the other side, so we have it as root 3 out of 2, then tan, then finally we put back a u. So on putting back a u, so you will have 2 out of, you can even put this 2 out of 3 the other side. Yeah, 2 out of root 3, this 2 out of root 3. So we have u minus a half is equal to root 3 out of 2 tan of root 3 out of 2 ln kx. Yeah, like that. Now we put back a u. So when we put back a u, so for u we shall have y out of x minus a half is equal to root 3 out of 2 tan of root 3 out of 2 ln kx. So we get the LCM and simplify. Getting the LCM, if we get the LCM this side, we shall have y minus 2y minus x out of 2x is equal to root 3 out of 2 tan of root 3 out of 2 ln kx. So finally, remember our aim is to get y. Finally, our 2y will equal to 2x times root 3 out of 2 tan of root 3 out of 2 ln kx plus x. Yeah, this x goes the other side, this multiplies that side, so this can cancel with that, and finally your y becomes x root 3 out of 2 tan of what? Of root 3 out of 2 ln kx, and then plus x out of 2. Yeah, x out of 2. Fully finalizing, our y eventually becomes x out of 2 into root 3 tan of root 3 out of 2 ln kx plus 1. This is our final expression. Thank you so much for watching. Thank you for watching. Thank you so much for watching. Please like the video. Subscribe if you haven't subscribed. Please subscribe. Share, because sharing is caring. Thank you so much. We meet in the next